Hey, what's good, Logan? Welcome back to another installment of Math from Your Couch. Today, the topic is going to be, we're going to combine two ideas. We're going to combine something from like back in fourth grade to something we did just about 2 to 3 months ago. So what we want to do is we want to introduce this idea of simplifying rational expressions. And a rational expression is just a fraction. So you'll notice that we have 4 examples right here, and all of them are fractions. We start off with our fourth grade version of fractions, and then it gradually extends and moves to something a little bit larger, to where you're looking at stuff that we did just in like the past 2 to 3 months ago. So a rational expression is just a fraction. What I'd like to do is I'd like to break it down into 2 different videos. Our first video is going to be focusing on these 2 guys right here. So our part 1 video is going to be on simplifying rational expressions where the top and the bottom, the numerator and the denominator, are both single term. Okay, monomials. You'll notice that these 2 fractions, there's no addition or subtraction. We call those monomials, where there's no addition or subtraction in the polynomial. And then our second video is going to be on simplifying these types of rational expressions, where on the top and bottom, or either the top or the bottom, you have a polynomial or you have addition or subtraction in there. So those are the 2 different types of rational expressions we're going to be focusing on. Today we're going to focus on the green ones. So let's get into it. All right, so there are 2 properties I need you guys to understand. The first property is that anything over itself, anything divided by itself, is going to equal 1 every single time. 5 over 7 over 7 equals 1. Now, in question number 2, property number 2 is the understanding that if you can take something that is being multiplied together and break it up, then any number on top of itself or anything over itself will break down to 1. And this is going to be our simplifying property. So this right here is the property of identities. Any number over itself equals 1. And this over here is what I'm going to call our simplifying property. Any number over itself is equal to 1. So it's just breaking it down to how it's going to look. All right, so let's see our first example. So our first example, we need to simplify 8 over 20. So we're going to simplify 8 over 20. So what you want to do is you want to break this down into multiplication, kind of like over here. So we need to think, what can you multiply to give us 8? I would say 2 times 4, and then you can break that down even further to 2 times 2. So we can say that 8 is 2 times 2 times 2. And 20 we can break down to 4 times 5. And you can break that down even a little bit further to 2 times 2 times 5. So our first step is to factor it. All right, so we're going to factor the monomials. And factor just means to break it down to multiplication. The second step is to find ones. All right, so we're trying to find equivalent ones. Any number on top of itself is equal to 1. So this will equal to 1. And this will equal to 1. And now we can simplify it. On the top, we have 1 times 1 times 2, which is equal to 2. And on the bottom, we have 1 times 1 times 5, which is equal to 5. So this simplifies to 2/5. Now, this shouldn't be anything new. It might be review, but it wasn't. It was seen last time in in fourth grade math, probably. All right, so let's take a look at our second example, which you probably didn't see in fourth grade, but looks more along the lines of something you might have seen in 8th grade or even more recently in Algebra 1. So we want to break this down. Well, there's nothing that can multiply to give us 5 other than 5 and 1, but I don't like writing down 1, so I'm just going to write 5 times and then x times x times x, because that's what x to the power of 3 means. And then on the bottom, I'm going to break this one down. 9 is 3 times 3, so we're going to go 3 times x times x. And now what I want to do is I want to find equivalent ones in the problem. And you'll notice that I can find an equivalent one here, so I'm going to simplify those 2 x's. And I can also simplify those 2 x's. Now, after I simplify those x's, the next thing I'm going to want to do is I'm going to want to simplify, I'm going to rewrite my answer, which is 5 times 1 times x. So on the top, I have 5x, 5 times x. And then on the bottom, I have 3 times 3 times 1 times 1, or just 3 times 3, which is 9. So from here on out, I'll probably stop saying the 1 times 1 part and just say the numbers that are not 1. So our example number 2, we have 5x over 9. Moving on to our second set of examples, what we have here is number 3, 7x over 42x to the second. So we're going to simplify this by breaking it down, by factoring it. So we're going to factor this thing. The top is going to factor to 7 times x. That's a straightforward one. The bottom, however, the numerator is going to simplify a little bit more. 42 is 6 times 7. So I'm going to go 6 times 7 times x times x. Now, some of you might realize that 6 can break down further, but you'll notice that there's nothing above on the top that's going to simplify with the 6. So I'm actually not going to break it down to anything smaller. The next thing I'm going to do is I'm going to simplify any equivalent ones. So any number on top of itself counts as a 1, 7 over 7, x over x. And now you'll notice that on the top, there's nothing left. A lot of times people will write 0, but remember, these numbers right here are technically now 1. And 1 times 1 is equal to 1. So I'm going to write 1 on the top over 6 times x, which is 6x. Now, if you don't remember if this is 6x or 1, it's this. If there's a number in the bottom that's not 1, you must write it as a fraction. So anytime the bottom has a number there other than 1, you must write it as a fraction. All right, question number 4, let's break this guy down. 18x to the 4th is going to be 9 times 2 times x times x times x times x. And then the denominator, I can simplify to 2 times x. Now the next question is whether or not I should simplify or break down, should I factor the 9 further? But you'll notice that there's nothing else to cancel with the 9 because the 2's will end up canceling each other out. So what we'll do is we'll simplify the equivalent ones, which is 2 over 2, and then the x over x. And now on the top, what I have is 9 times x times x times x, or 9x to the power of 3, over, and then the bottom I have 1. So our answer is 9x to the power of 3 over 1. Now, if you want, you can actually simplify this one step further, is that any fraction with a denominator of 1 does not need to have its denominator written. So we can just write 9x to the power of 3. All right, this is what your assignment's going to look like. If you have any questions, please give me a text or an email, or you can hit me up on Google Classroom. If all else fails, you can always come by office hours, and I'm be more than happy to help you out then. Until then, I'll talk to you guys later.